Ever stared at a can of meat, wondered what's going on in there? It's a common pantry staple, a quick meal, a survival food. But how does that meat get into that can? It's not magic, folks, it's science. And a whole lot of engineering. We're going to pull back the curtain. We will reveal the journey from farm to can. It's a fascinating trip, trust me on this one. You might be surprised by the precision involved. This isn't your grandma's canning, though she was a pioneer. This is industrial scale. Think big machines. Think shiny stainless steel. Think about rules. Lots of rules for safety. The goal is simple. Deliver safe, stable, and tasty meat. Meat that can sit on a shelf for a long time, without spoiling, without losing its goodness. This process has been refined over many decades. It's a testament to food technology. So, what exactly are we talking about? Canned ham, perhaps? Corned beef hash? Maybe some potted meat product? The principles are largely the same. It's about preserving meat, using heat and a sealed container. Let's demystify the can, shall we? It's time to see how the sausage, or rather, the canned meat, is made. It all starts with the star of the show, the meat. You can't make good canned meat with bad ingredients. It's a fundamental rule of cooking, any cooking. Factories use various types of meat. Beef is common, pork is popular too. Chicken finds its way into many cans. Sometimes it's turkey. Even fish gets the canning treatment. The choice depends on the final product. What are we trying to make? Quality inspection is not just a suggestion, it's a must. Before any meat enters the processing area, it gets a thorough check. Veterinarians and quality inspectors are on the front line. They look for signs of disease. They check for wholesomeness. They ensure the meat meets strict government standards. Only the best cuts, or rather the approved cuts, make the grade. This isn't about prime rib necessarily. It's about suitability and safety. Think about it. This meat is going to be preserved. Any existing issues could be magnified, or worse, they could pose a health risk. So temperature control is vital from the get-go. The meat must be kept chilled. This slows down any bacterial growth. It maintains freshness. Once the meat passes inspection, it moves to the prep area. This is where the transformation really begins. Think of it as the butcher shop, but on a much larger scale. The first order of business is trimming. Skilled workers, or sometimes precise machines, remove excess fat. They take out bones if needed. They get rid of any gristle or connective tissue. The goal is to get clean, usable meat portions. This ensures a better texture in the final product. Next comes cutting. Depending on the desired product, the meat is cut. It might be diced into small cubes. It could be sliced, or it might be ground. Large industrial grinders, choppers, and dicers handle this task. These machines are powerful. They are also designed for hygiene. Stainless steel is the material of choice. Easy to clean, easy to sanitize. The size and shape of the cut are important. It affects cooking time. It affects how the meat fits in the can. Some meats get a pre-cooking step. This isn't the final cook, mind you. It's more like a blanching or partial cooking. This can help remove some initial water content. It can firm up the meat. It can also render some fat. For example, bacon pieces might be partially cooked. This makes them easier to handle and pack. Pre-cooking methods vary. Steaming is common. Now we have our prepared meat. It's trimmed, cut, maybe pre-cooked and seasoned. The next stop is the filling station. This is where the meat meets its final home, the can. The cans themselves arrive at the factory clean and empty. They are often made of steel or aluminum. They might have a special lining inside. This lining prevents the metal from reacting with the food. It protects the flavor and quality. The filling process is usually highly automated. Think complex machinery. Conveyor belts whisk empty cans into position. Precisely engineered fillers dispense the meat. These fillers are amazing pieces of kit. They can handle different types of meat, chunks, slices, or ground meat. They measure out the exact amount for each can. This is important for consistency. It ensures each can has the correct net weight. No overfilling, no underfilling. Sometimes it's not just meat. Other ingredients might be added. Perhaps some gravy or broth, maybe vegetables like potatoes or carrots in a stew. These are added by separate dispensers, all synchronized with the meat filling. The machinery works at high speed. Hundreds, even thousands of cans can be filled per minute. Once the cans are filled, they move to the seamer. This is where the lids are put on. But it's not just about slapping a lid on top. Oh no, there's more science at play. We need to get rid of a troublemaker, oxygen. Oxygen is the enemy of shelf life. It can cause food to spoil, it can lead to off flavors, it helps unwanted microorganisms grow. So, we need to give it the boot. This is where vacuum sealing comes in. As the lid is placed on the can, air is removed from the headspace. The headspace is that small gap, the gap between the food and the top of the lid. Some systems use steam. They inject steam into the headspace. This pushes out the air. When the can cools later, the steam condenses. This creates a vacuum. Other systems use mechanical vacuum pumps. They suck the air out directly before the lid is permanently sealed. The seaming process itself is a mechanical marvel. The lid and the can body are interlocked. They form an airtight seal. The cans are filled, they are sealed, but the meat inside is still essentially raw, or only partially cooked. Now comes the most important step for safety: cooking and sterilization. This happens in massive pressure cookers. These are called retorts. Think of them as giant industrial autoclaves. They are built to withstand high pressure and high temperatures. This is where the magic and the science of preservation truly happens. The sealed cans are loaded into these retorts. Crates of cans roll in. The doors are sealed shut. Then, hot steam or superheated water is introduced. The temperature inside the retort climbs. It goes well above the boiling point of water, often to 240 to 250 degrees Fahrenheit. That's 116 to 121 Celsius. The pressure inside also increases. This high temperature is crucial. It kills any bacteria, yeasts, or molds, including the nasty ones like Clostridium botulinum, the cause of botulism. The cooking time and temperature are precisely calculated. It depends on several factors: the size of the can, the type of food, the acidity of the food. Food scientists figure this out. They do heat penetration studies to ensure the coldest spot inside the can reaches the sterilizing temperature and stays there for long enough. After their intense heat treatment in the retorts, the cans are hot, very hot. They can't just sit around. If they cool too slowly, the food inside might overcook. This can affect the texture, it can affect the taste. We don't want mushy meat, we want perfectly cooked meat. So a controlled cooling process is next. This is just as important as the heating. It stops the cooking process at the right point. The cans are typically cooled with water. Sometimes they are moved through cooling canals, or they are sprayed with chilled water. The temperature needs to drop relatively quickly, but not too quickly. Rapid, uneven cooling could stress the can seams, or even damage the cans. So it's a carefully managed process. Once cooled, the outside of the cans must be dried. This prevents rust. It also prepares them for the next stage, getting dressed up. Now it's time for labeling. The plain, cooled cans move along another conveyor. They head to the labeling machines. These machines are fast. They can apply labels with incredible speed and accuracy. The labels contain important information: the product name, of course, the brand, the list of ingredients, nutritional information. Before any can leaves the factory, it faces more checks. Quality control is a continuous process. But there are specific final checks. These are designed to catch any issues that might have slipped through earlier stages, or problems that occurred during cooking and cooling. Safety is always the top priority. So samples are often taken from each batch. They go to the lab for testing. These lab tests can check for several things. Microbiological safety is key. They confirm that the sterilization process worked. They might also check the chemical composition, things like salt content or fat content, to ensure it matches the label. Physical checks are also done. Inspectors look for damaged cans, dented cans, improperly sealed cans. They check the weight of the cans to make sure they meet the declared weight. Some factories even use X-ray machines to detect any foreign objects. Taste tests are also part of the quality control. Yes, people actually taste the product. Trained panelists sample the canned meat. They check for flavor, they check for texture, they check for appearance. Does it meet the company's standards? This sensory evaluation is important. It ensures the product is not just safe, but also enjoyable to eat. So there you have it, the journey of canned meat, from carefully selected raw material, through a gauntlet of preparation, filling, and sealing, into the fiery heat of the retort, then cooled, labeled, and rigorously checked. It's quite a trip, isn't it? It's a process that combines traditional preservation ideas with cutting-edge technology and strict scientific principles. It's not just about putting meat in a can, it's about doing it safely and consistently. This whole operation is a testament to modern food engineering. Every step is carefully designed, every machine is precisely calibrated, every worker is trained in hygiene and safety. The goal is to produce a product that is shelf-stable, a product that retains its nutritional value, and a product that tastes good, even after months or years on a shelf. This reliability is what makes canned meat so useful, for everyday meals, for emergency preparedness. Think about the science involved. Microbiology, to understand and kill harmful bacteria, thermodynamics to manage heating and cooling, mechanical engineering to design and run the complex machinery, food chemistry to ensure flavor and texture are preserved. And that, folks, is how it's made. Good eats indeed.